Oh, hey guys, Assalamu alaikum. So I was just watering the plants and I was wondering how fast is the water flowing through this pipe? So how many particles of water are flowing through this pipe per unit time?
Now there's a piece of hard work. How do we even measure the amount of water passing per second? I mean, how do you even count those particles of water? They're so tiny we can't even see them, right? So perhaps an easier way of accomplishing that would be, rather than counting the number of particles, let's just count the amount of water in terms of a standard unit of measure of liquids, right? So we'll just measure it in terms of mLs or liters, or scientifically you could say centimeter cube or meter cube, right? So that's going to be a whole lot easier. So let's look at it in a bit more detail, shall we? So we've got a pipe of water that is carrying some particles of water, of course. So here are the particles of water that are flowing. Of course, they're all flowing in a given direction. So they're all flowing unidirectionally, which means there's a current of water in there, right? Current refers to a flow of something in a given direction, like air current or water current, etc. And all you have to do is basically calculate the amount in liters or milliliters, the standard unit of measure for water, per unit time. So how fast is the water flowing through that pipe? Well, you can calculate it by just simply measuring the amount of water that's flowed and the time taken, right? Well, this concept is quite similar to what goes on in an electric current. So in an electric current, rather than water particles flowing through a pipe, we've got electrons that are flowing through a conductor. More correctly, they can be any electrically charged particle that is flowing in a given direction, right? So typically these are electrons in the metallic conductors. The electrons are basically those that belong to the outermost shell that join the sea of delocalized electrons. So once they've joined the sea of delocalized electrons, they're now loosely attracted to all of the metal ions in general, rather than a specific metal atom, and hence, because they're so loosely attracted to the individual ions, so the electrons are able to flow, right? So that's how things work in a regular setting. Right, so when we talk about electric current, we're basically talking about how fast electrical charges are flowing through a conductor, right? So electrical current refers to the rate, meaning how fast are those electrically charged particles. So the rate of electrically charged particles flowing through a point per unit time, which of course is just the second, right? So how fast are those particles flowing, those electrons, to be a bit more specific, flowing through a conductor per unit time? Well, that's what electric current is all about. Electric current is measured in amperes or amps, right? So mathematically, what this looks like is electric current, denoted by the symbol capital I, is equal to an amount of charge, and this amount of charge isn't just an electron. This amount of charge is in coulombs that are flowing per unit time. So electric current in amperes or amps is the amount of charge just like those mLs or liters. So we're not counting the number of electrons per se. So this is the number of coulombs of charge, which is the standard SI unit for measuring electrical charge, flowing per unit time in seconds. And just FYI, a coulomb of charge is like a liter or a lot of particles, right? So it's precisely 6.24 times 10 to the power of 18. So 6.24 billion electrons make 1 coulomb of charge, right? So that's the mathematical expression to determine what electrical current is. Now, electrical current, as you'd expect, has a direction of flow as well. And you know what? The earliest scientists, when they started studying electricity, they thought that the charges that were flowing were not the electrons, which are negatively charged. They thought positive charges were flowing through the circuit. Which is why they thought that electrical charges would start flowing from the positive terminal of the battery all the way through the circuit back to the negative terminal of the battery, right? So this is basically known as the conventional current. Okay, so this is conventional current. But we know better than that by now. So we know that the reality of the matter is that electrons flow in the circuit belonging to that sea of delocalized electrons, remember? So electrons flow starting at the negative terminal of the battery and flowing right through to the positive terminal, right? So you've got electrons flowing opposite to the direction of the conventional current. But since that trend has set in so well, we still follow the conventional convention, right? So this is the real flow of electrical charges. It's called the direction of electron flow, and it is opposite to the direction of conventional current. So we'll have a look at some examples on how to calculate current using that equation that we learned earlier on, inshallah. So please be sure to go through the description to make sure you've learned everything there was to learn in this video. So take care and goodbye.